For this, I just do them all. Doesn't matter. Okay.
So for those of you that were absent, yesterday we started factoring, and everybody should have a foldable in their folder. That foldable is going to help us know what's step one. Well, step one is the first flat. Okay, what do I do for step two? Step two is the second flat, and that's what we're going to work on today. So yesterday we worked on step one. Step one in factoring is to always look for a greatest common factor. And so yesterday we talked about how that greatest common factor means the biggest number that'll divide into everything. And then the variables to the lowest degree, or lowest exponent. So that's what our GCF is, the biggest number that divides into everything, and then the variables to the lowest exponent. So those of you that weren't here yesterday, when we looked at this first one, we said 2x plus 42y. The biggest number that divides into them is 2. Now we look at the variables, x and y. They don't have anything in common, so we can't factor out. So when we take this 2 out, we're basically dividing it out of every term. So 2x divided by 2 leaves me with an x. 42y divided by 2 leaves me with 21y. And this is the factored answer. Now on this one, we have 4x to the fourth and 24x cubed. The biggest number that can divide into both of those is 4. And the biggest variable that can divide into both of those is the variable to the lowest exponent, x to the third. So when I take out a 4x to the third, I showed you the division yesterday, so we can go, ooh, that cancels x, and then x cubed cancels with that here. Now, the other way we talked about it is we said, all right, what do I multiply this by to end up with 4x to the fourth? And we decided it was just an x. So we talked about those two ways of thinking about it. You can either think about it as division, or, ooh, what do I multiply this by so that I get this? Okay, on these two, a 2 will divide into the numbers, and they have an a and a b in common. On this one, a 4 will divide into the numbers, and they have an x and a y in common. So our greatest common factor is the biggest number that will divide into both of them, and then the variables that they have in common to the lowest degree. So that's what we're doing. We're factoring out the largest number that divides into all the terms, should say. I left off the s yesterday. Let me check in this. And variables to the lowest degree. Okay, so let's try a few. Make sure we understood what was going on yesterday. We can do that in your notebook. Yes, do that in your spiral bound. Okay, so this is our warm-up over greatest common factor. And math teachers abbreviate greatest common factor as GCF. Okay, so number 1 is 14x squared y minus 21x. And number 2 is 4x squared minus 8x plus 6. Let's try those two. Now, I'm going to cut off my mic and walk the room. If you need help on these, you ask. Let's see what's going on here. I think everything has a correct answer. Let me check it. 86.
86, that's 56.
This is, I'm sorry, 56. You said 86.
No, I just said 86. Just I was wondering, it's just 5
What? This? Okay, when you add them, it's going to start changing.
Oh, I'm sorry. Still
sevens, because 7 times 10 is 14, sometimes 3, 21. So 7 parentheses. So see how it's laid out. So yeah, so now it's 2 exercises.
Here we have 1. Here we have 2. So there's 1 more here.
So all of this is to
Here we go.
Yes, this would be 2
Now,
odd
we
times
will
across.
have that. So we have this is 1. This one doesn't have
I'm not looking at myself.
I just get something to do in 7th grade, and I feel like math class every time.
I need a little knock code.
Oh, it's easier than
I put a root beer in there first. Now I have there's 0.
right to yesterday.
Remember Debbie Dixon? Me and him, we used to be best friends. I don't know how long
It was 0. That was
Okay, so for 5th grade,
No, it was not. That was
for summer 5th grade, I'd go to his house all the time. I'd sleep over there like all
goes
week.
away. It's so sweet.
We'd go to the quickie, buy 2 2-liters. We both have one in the morning because they're at night. I'm surprised we didn't get fat as hell because we would buy pizza orders, have it come to the house, and we'd just be playing video games. The whole time. Yeah, the whole time. For real. And his mom would buy us a box of cereal about this big and we'd go through in one day. I have a high metabolism, so I think about yeah, that's just.
How do you do this when you just like grandma?
Yesterday, I was working out. My brother comes downstairs. I'm working out like 1 o'clock in the morning. My brother comes downstairs and starts talking about his girl problems, and I'm like, he's fine. But I have no shirt and I have my workout pants and those are so I'm just like, I'm offered a little like, he's just talking to me. I'm like, can you go to bed? I feel very awkward.
Okay, guys, let's take a look at these two. Now, what I'm going to do in here is, even though we're going to learn something a little bit new every day, we're also going to do mixed review every day so that we can talk about, when I see this one, let's go through my steps. Step 1 is to always look for a GCF, which is what we did yesterday. So when you look at these two, and you're looking for a greatest common factor, the number that divides into both of these is what? 7. What variables do they have in common? X. Okay. 2 ways you can think about it. This term divided by this, or you can say, all right, what do I multiply 7 by to get 14? 2. Okay, out here I've got 1x, but up here I need 2. So I need another x here. And down here I don't have any y's, but up here I do. So I need a y. Does that make sense? Yes, Toby.
I had a question. I'm doing it right, I think, but it feels like you just like add random stuff.
It may feel like that for a little while. As long as you keep getting them right, we're good. If we start missing them, let me know, and then we'll have a sit down. Okay. What do I multiply 7 by to get negative 21? A negative 3. Okay, I've got an x right here and 1x right there, so do I need any more in here? No, I'm done. Now, if it feels like I'm just doing random stuff, what you can do to check and make sure it makes sense is kind of go backwards and multiply. This would be a check step, and you don't have to do it, but it does help you see that it makes sense. Because 7 times 2 is 14, x times x is x squared, and there was a y. 7 times negative 3 is negative 21, and there was an x. Do you see if I multiply this 7x through, if I distribute it, I get what I started with? Yes, sir.
I put down 7 parentheses 2x squared y minus 3x.
Okay, so you factored out the 7, but to be completely factored, which is what your directions say, factor completely. To be completely factored, we have to factor out the numbers and the variables.
Okay.
Okay? Alright, this one. This one only has a number in common, doesn't it? There's no variables in common. This one has an x, and this one has an x. But does this term have an x? No. So all 3 terms don't have a variable in common. So all we can factor out is a constant. What's the biggest number that divides into 4, 8, and 6? 2. And when I divide it out, or I can say, okay, what do I multiply 2 by to get 4? 2x squared. What do I multiply 2 by to get negative 8? Negative 4x. What do I multiply 2 by to get positive 6? Positive 3. And that's all I can do. That one's completely factored. Yes, Jordan?
How come there wasn't a 2x on the outside?
Of this one?
Yeah.
Okay. When we're looking for the variables, every term has to have that variable. So this one does, but this one doesn't. And because this one doesn't have an x, we can't take out the x. They don't all have it in common. Okay, here's your challenge problem.
Oh my god.
That's it? Or no more?
That's all I'm going to do. Here's your challenge problem. So we've got bigger numbers, and our variables have higher degrees. So let's see what you can do with this one.
We still take those in. Right? Yep.
You could 6 times what equals 40. 6 times what equals 40. So it has to be more.
Okay, I don't know what I'm
8 times.
Bigger number.
Yeah, I think
do we have a C? A equals to B. That's how we know. Biggest number.
First one, outside the pizza.
What's the biggest number?
What do you get?
Yeah.
I thought we agreed.
There you go.
Now, you're gonna do your very
No, that would be
lowest exponent for A is 3, and the lowest exponent for B is 6. Okay. Now you do the variance. The lower exponents, we've got 5, we've got 3. So we're gonna go 3. Okay, now let's look at these. We've got 2 and we've got 4. So let's go below 2. 24 divided by 8. All that's got to go out. What's the biggest number? We're going
Got it.
40 divided by 8. Box. Here I have 3. Here I have 3. Okay, squared. The A is 5 is
Like, and then you just see the bar and you're like, that's and then you just end up
Solve the matrix.
I swear, it's so pretty. Like, in that book.
Alright.
I like to find a
Okay. I picked this one because I thought the first number you were going to think of was 4. Was I right?
I don't know.
Okay. My pen's going crazy. So, the largest constant, the largest number that divides into both of these is 8. 8. Okay. And then we look at the variables. They both have an A in common, and the lowest degree is 3. They both have a B in common, and the lowest degree is 2. Okay.
You got it right. Hey.
Yes, sir. Yes. All right. 20. What do I multiply 8 by to get 24?
3.
3. Okay. Here I have 3, but I need 5. So how many more goes in here?
A squared.
2. Here I have 2, and I only need 2.
Nothing.
So I need no more. Okay? 40 divided by 8 is 5. Okay, here I have 3, and I only need 3, so no more A's. Here I have 2 B's, and here I need 4, so I need 2 more.
I was right. I solved the matrix.
Makes a lot more sense than that.
Good. Good. Okay, now, our class is kind of split because some of you have teachers that quizzed Monday, and some of you have teachers that quizzed yesterday. So some of you did this yesterday. Raise your hand if you did this yesterday. About 4 of us. Okay. And the rest of us will be doing this today. Okay? We're going to look at the next type of factoring today. We're not going to go fast. I'm going to make sure we understand that this is the next type of factoring we're going to look at today. Okay. Step 1 in factoring is to always look for a GCF. Step 2 is to look and see if we have a trinomial. Because this says, our directions say trinomial factoring. If we don't have a GCF, but we do have a trinomial, these are our next steps.
Your flower fell off.
Bummer.
Yeah.
All right, I'll work on that.
I'm pretty for
All right.
Okay.
I'm going to show you my method, and then I'm going to show you another visualization of it that you might see other people do. When we have a trinomial here, what we're trying to do is break it down into 2 binomials. And the process is, step 1, ask yourself what you multiply to get this number, that you, step 2, add to get this number. Now, those of you, have any of you ever been to tutoring and they did this big X thing? No, y'all haven't seen that. This is just a way to visualize it. What do you multiply to get this number that you add to get this number? So, this is the same thing. I don't usually draw the X, but some people like the X. What do you multiply to get this number that you add to get that number? Okay. Yes.
That's like 6 times 2 and 6 plus.
Okay, 6 times 3 gives you 18.
No, I was talking about something different. Like 6
Okay.
plus 2 equals 12, and then 6 plus 6 is 12.
We get there, like that, yes. Okay, so what 2 numbers can I multiply to get 18?
6 times 3.
Okay, that's one of them. But if I add 6 and 3, does that give me 11?
9.
Okay, so that didn't work. So 9 and 2. All right, so I'm going to say 9, positive 9, and positive 2. If I multiply them, I get 18. If I add them, I get 11. So how this breaks down is it breaks down into x plus 9 times x plus 2. Okay. Now, I'm going to do a check step, which you don't have to do. You don't even have to write this. But I want you to see that it works. When we multiply binomials, we distributed the first term, and that would give us x squared plus 2x. And then we distributed the second term, and that gave us 9x plus 18. And then we always check to see if we can combine these two. X squared plus 11x plus 18. Do you see I got what I started with? So this is the factored form. Factored just means I'm writing it down as the polynomials that multiply to give me that number, that polynomial. These 2 binomials, if I multiply them, they give me that trinomial. So you don't have to do the check step. This is just the check step. That's just the check step. This is our answer. Okay, so let's look at example 6. You're asking yourself, step 1, what do I multiply to get this number? That I, step 2, add to get that one. And if you like the x, you can do the x. If the x just bothers you, don't do it. So multiply for 14, add for 9. Okay. 7 and 2. Very good. We need a positive 7 and a positive 2. So this breaks down into, instead of x this time, what variable are we using? M. M plus 7 times m plus 2. Okay, let's do a big line right here. And I'm going to do an example 6b. I'm not going to change much at all. I'm going to change it to where it says m squared minus 9m plus 14. Okay, so when I just change that one little sign, this time we're multiplying to get positive 14. But we're adding to get negative 9. Now when we multiply and get a positive and add and get a negative, the two numbers just have to be negative. So if this is positive, multiplying to get a positive, but adding to get a negative, all it does is change those to negative. So this gives us m minus 7 times m minus 2. Very close to the same problem. All I did was change that sign of the middle term. Yes, sir?
An optional choice, or is that like when we get to questions?
It's when we get to questions like that. Yeah. This is the answer for this problem. This won't work for that one. Okay. So, this is similar to that. I want you to try. This is going to be a you try. And I'm going to walk the room. So think about multiplying to get this number, adding to get this one. And making the x makes it easier for you, then do that. If you don't need it, don't buy it. Think about the things that you multiply. One of those, two, four. That's it. Okay. Which ones of those can we get negative 6?
So I do.
Good. Except I'm going to use a y. There's a y right there.
Excuse me, Miss Wendy. Are you with it?
This is a negative.
What? I know, it's really bad.
Yes.
Because it was hot all the time. Yeah, I just walked around.
I would.
It's very bad. Come on. I mean, I know some girls don't always watch, but
You should hear. No, something.
would I just do y squared minus x plus
So the end of it,
I don't know what we got that. Okay.
Many of us call them the gals.
All right, guys. I can tell from the talking that we have mainly finished this problem, so let's take a look at it. Okay. a lot of you can do it without doing the x, and that's great. What can we multiply to get a positive 8? Then we can add to get a negative 6. So we know it has to be negative and negative, and you're right, it's negative 2 and negative 4. Now, if you wrote y minus 2 times y minus 4, you're right. But because multiplication is commutative, if you wrote y minus 4 times y minus 2, you're right. The order of the binomials doesn't matter. What matters is the signs and the numbers that are inside. So you could put either binomial first and be absolutely correct. Okay, the last one, I'm actually going to, just like I did on number 2, I did 2 different versions. I'm going to do 2 different, not number 2, 6, number 6. I'm going to do 2 different versions of this one too. So for the next one, I'm going to do w squared minus 2w minus 15. I'm going to do the same thing I did a minute ago. So this is 2 different examples. We'll call this A, we'll call this B. They're different problems. Okay, so if we look at this one, this is where we have to put our thinking caps on. Because the last term is negative. I'm multiplying to get a negative. Whenever I multiply to get a negative, one of the numbers has to be positive and the other one has to be negative. That's the only way to multiply to get a negative. And I'm adding to get a positive. Well, if I'm adding and getting a positive, that bigger number has to be positive. So this is 5 and negative 3. Because 5 times negative 3 is negative 15. And 5 plus negative 3 is 2. So this breaks down to w plus 5 times w minus 3.
Did we learn this today in our math class?
Huh?
Did we learn this today in our math class?
Yes, you should. Yes, Maddie.
Does it matter what side of the X numbers go on?
No, it doesn't. The signs of the numbers matter, but where you put them doesn't. Okay? Now, let's take a look at this one. We are multiplying to get negative 15 and adding to get negative 2. If we're multiplying to get a negative, it has to be positive and negative. But because we're adding to get a negative, the bigger number has to be negative. So it's still 5 and 3, but this time it's negative 5 and positive 3. Because negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. Okay, so if the last term is negative, your 2 factors will have different signs. And you determine the bigger number positive by looking here. The bigger number is positive if this is positive. The bigger number is negative if that is negative. Okay, so to summarize, what do we do when we have a trinomial? X squared plus any number times x plus c. What do we try to do that to factor it over the set of integers? Okay, what was our step 1? You ask yourself, what do you multiply? That was interesting. To get the constant. In this case, the constant is represented by what letter? The number at the end is represented by C. What do you multiply to get the constant? Constant means plain old number. That's what constant means in math. And in our case, it's represented by the letter C. And then the second thing is you ask yourself, what do you add? To get the coefficient. That's another math term, coefficient. just means the number that's multiplied in front of the variable. What do you add to get the coefficient of x? And in this form, it's represented by the letter B. And that's how you factor Okay. Questions about that? Okay. I would like us to put the foldables back in our folder. Now, as soon as we're done in here with our foldables, you get to take it to study for class. Now, if you like these notes, where can you find the notes every day? Website. Okay, and today